continue along with chapter 7, section 7.2. We're going to be multiplying and dividing rational expressions. So we're still going to be using the simplifying rational expressions that we saw in section 7.1. But before we simplify, we're going to be doing some multiplying and dividing. So it's just like with regular fractions. And so to start with multiplying rational expressions, we're going to take a look back at regular fractions first. So this is something I like to do in pretty much this entire chapter, because if you can relate this back to regular fractions, it's going to make working with these rational expressions a little bit easier. So if we recall, let's go ahead and look at, it's going to be an ugly example. Well, it looks ugly, but it's not. So 13 over 49 times 7 over 39. Now, if we were going to go ahead and multiply, there were two ways that you kind of learned from multiplying fractions. You can multiply straight across, and if we did that, we would have 49 times 39 on the bottom. That's going to be a really big number that I don't want to have to multiply by or reduce with. So if we go ahead and actually reduce first, and the reason why I picked an example like this where we kind of have to reduce first is because this is what we're going to be doing with rational expressions. So if we go ahead and reduce first, if we look at 13 and 39, remember you can reduce as long as you have something on the top and on the bottom of a fraction, and it can be across fractions. It doesn't have to be within the same fraction. So 13 and 39, 13 goes into both of them. 13 goes into 13 one time. 13 goes into 39 3 times. And then if we look at the 7 and the 49, 7 goes into 7 one time. 7 goes into 49 7 times. And now if we go ahead and multiply across, on the top we have 1 times 1 is 1. And on the bottom, 7 times 3 is 21. So instead of having to deal with the 49 times 39, we were able to reduce and get really nice numbers at the end. This is what we're going to do with rational expressions. So let's go ahead and look at some examples with multiplying rational expressions. So we're told to multiply and then write in lowest terms. So write in lowest terms means reduce or simplify. And so that's what we were doing in the last section. So first one here, we're not going to be dealing with any kind of factoring. For these, we're going to have 3m squared over 2 times 10 over m. So before we multiply, let's go ahead and reduce first. So if we look at the numbers, we have a 3 on the bottom and 3 on the top, 2 on the bottom. Those can't reduce, but I can reduce the 2 and the 10. 2 goes into 2 one time. 2 goes into 10 5 times. Those are the numbers taken care of. Now, if I look at the variables, I have 2 m's on the top, 1 m on the bottom, so I can cancel out 1 m, and I'm left with 1 m on the top. So now, if we look along the top, we have a 3, an m, and a 5. 3 times 5 is 15, and we have an m. And on the bottom, we just have a 1. But any number or variable divided by 1 is itself. So we're going to write this as 15m. So that's all we're doing with multiplying. Really similar to the simplifying we were doing before, except now we're just simplifying between two fractions instead of one. That's really the only difference here. Let's go ahead and look at a couple more of these. number 2, we have a plus b over 5 times 30 over 2 parentheses a plus b. All right, so again, remember, if you ever see addition, you cannot cancel the a or the b separately. They have to go together. So put in those parentheses and remember that those are stuck together, which is good because in this one, we have an a plus b on the top and an a plus b on the bottom. So we can go ahead and cancel those two out. And now if we reduce the numbers, 5 and 30 can be reduced, or you could reduce the 2 and the 30. Doesn't actually matter which one you do because we're going to have to reduce twice either way. I'll do the 5 and the 30 because the 5's a little bit bigger, so it'll make it smaller. So 5 goes into 5 one time, 5 goes into 36 times. And now at this point, we could reduce the 2 and the 6 here. I'm going to do it in the next step just because it can get kind of messy if you reduce again with the same number. So along the top, we have just a 6. On the bottom, we have 1 times 2, which is 2. And 6 divided by 2 is 3. Okay, and then for this last one here, this would be the point where since we've practiced a couple of them, I would go ahead and try this one and then check your answer with mine. I'm actually gonna change this one up a little bit. So this one, let's go ahead and do 12 parentheses m minus 6 squared over 7 parentheses m plus 2 squared times 21 times, so parentheses m plus 2, and on the bottom, 4 parentheses 6 minus m. Okay, so let's look at the numbers first because those are going to be a little bit easier to deal with. So on the top of the first fraction, we have a 12. Over here, we have a 4. 4 goes into 4 one time. 4 goes into 12 3 times. Now, if we look at the 7 and the 21, 7 goes into 7 one time. 7 goes into 21 3 times. The coefficients are taken care of. Now, if we look at our variables here, they're all grouped up, so we're going to be canceling out an entire group. So on the bottom here, we'll deal with the m's and the 6's after because those are a little different. We have an m plus 2 squared, meaning we have 2 m plus 2's. On the top, we have 1 m plus 2. So I can cancel out 1 m plus 2 from the top and 1 n plus 2 from the bottom, but we're still left with 1 m plus 2. So we had 2 of them, we got rid of 1. You can always write that out as m plus 2 times m plus 2 and cancel it out that way if it makes a little bit more sense to you. But either way, we're left with 1 of them. And now, if we go ahead and look at this m minus 6 squared and the 6 minus m, if you remember from the very end of section 7.1, m minus 6 and 6 minus m are opposites. So now what we're going to do in order to deal with these, I'm use a different color here, we're going to cancel out 1 from each, just like we did with the m plus 2. So we're left with 1 m minus 6 on top. And because we canceled out an m minus 6, this one that we canceled out on the bottom is actually going to become a negative 1. Because remember, m minus 6 and 6 minus m are opposites. Now, if we go ahead and see what we have left, on the top we have a 3, an m minus 6, and a 3. 3 times 3 is 9, parentheses m minus 6. And on the bottom, we have a 1 and a 1. Those don't do anything. We have an m plus 2 and a negative 1. So we have negative 1 times m plus 2. Now, if trying to remember what the homework wants you guys to do. If we were in person and this were on the test, this would be perfectly acceptable. The homework is going to specify if they want you to multiply it out. So I'll double check that in a second and actually let you guys know. The other thing we can do is distribute this in. So if I were to distribute, we would get 9m minus 54. And on the bottom, distribute in a -1, we get -m minus 2. Either of these are correct. Let me go ahead and actually just check what MyMathLab wants you guys to do. Okay, so it looks like MyMathLab doesn't care if you leave it like this one. And most of the time, I would actually leave it like this, so don't distribute. Because if you're on a test and you distribute, you do one extra step, that's one extra step where you could make some kind of mistake, whether it's arithmetic, you distribute wrong. So I would actually just leave it like this. But again, it's up to you. And sometimes MyMathLab will tell you to multiply it out, depending on the problem. But I always recommend leaving it in factored form so that you don't have to potentially make another mistake or make a mistake, assuming you didn't want to make one earlier in the problem. But that's up to you guys. If you want to go one step further, you can. Okay, so all of those were already factored for us. Now let's go ahead and try a few problems where they are not factored for us. So there's going to be some extra steps. So I'll go ahead and actually just make a new page. That way we have tons of room. So for these examples, we're told to, again, multiply, then write in lowest terms. So it's the exact same type of question, but we're given stuff that isn't factored. And so the trick for these is to factor, reduce. By reduce, I mean cancel, and then multiply. So just like we were doing with simplifying expressions in section 7.1, we always factored first and then canceled things out. Same thing here. So this first one, we're given x squared plus 7x plus 10 over 3x plus 6 times 6x minus 6 over x squared plus 2x minus 15. Now, if you take a look at this, if we were to go ahead and multiply first, that would be some ugly multiplication because we would have to multiply this trinomial on the top with 6x minus 6 and 3x plus 6 by x squared plus 2x minus 15. That's some ugly multiplication, and we would end up having to factor anyway so that we could simplify. So never multiply first, always factor first. So let's go ahead and look at the first trinomial here. We are multiplying to 10, adding to 7. So think about what two numbers that would give you. That would give you 5 and 2. So I'm going to go ahead and just write that down straight away. So x squared plus 7x plus 10 becomes x plus 5 times x plus 2, or the other way around. But we go straight to the parentheses because it's just an x squared. On the bottom of that, we have a 3x plus 6. All we can do here is factor out the GCF. And what is the GCF? GCF is 3. Get rid of the 3 and we're left with an x. 6 divided by 3 is 2. So you should already notice some things kind of matching up that you'll be able to cancel. And now we have 6x minus 6 on the top. Again, all we can do is take out the GCF of 6. Get rid of it from the first term and we're left with x. 6 divided by 6 is 1, so minus 1. And on the bottom here, we have an x squared plus 2x minus 15. So what are we going to multiply to in this one? We're going to multiply to a negative 15, add up to 2. Don't forget your signs that you have to take with the number. So we know we need a positive and a negative. And because we are multiplying to a 15, negative 15, our two numbers are going to have a difference of 2. So that means we're going to have 5 and 3. And the 3 is going to be the negative one so that we add up to a positive 2. So let's go straight to parentheses, x plus 5 times x minus 3. Now, before we multiply, we're going to go ahead and cancel. So try to see what you have in common that you could cancel or reduce. And it doesn't matter what you do first. If you want to cancel groups, that's fine. If you want to reduce numbers first, that's fine. Just make sure you're reducing numbers that are in front by themselves. So like I have here, we have a 3 and a 6. I can reduce that to a 1 and a 2 because 3 goes into 3 one time, 3 goes into 6 two times. And now we can cancel groups. So I can cancel an x plus 5 and an x plus 5. And I can also cancel an x plus 2 and an x plus 2. We can't cancel these x minus 1 and x minus 3 because they're not the exact same group. Now, if we take a look at what we have left, on the top we have a 2 times x minus 1. And on the bottom we have a 1 times x minus 3. That's just x minus 3. And again, if you want to distribute on the top, go for it. I'm just going to leave it in factored form. All right, let's go ahead and try another one of these. Let's go ahead and do, let's do x squared plus 3x over x squared minus 3x minus 4 times x squared minus 5x plus 4 over x squared plus 2x minus 3. Okay, so this is pretty similar to the last one we did. So I would definitely go ahead and pause the video, try the problem, and then check your answer with mine. There's just a lot of factoring to do in this one, which is the most time-consuming part, but then canceling shouldn't be too bad. So let's go ahead and factor. The top left, we have an x squared plus 3x. X squared plus 3x. It's not a trinomial, so we're not going to use the big X. All we can do here is take out an x, and we're left with an x plus 3. On the bottom here, 3 terms, so we're going to use our big X. We're multiplying to a negative 4, adding to negative 3. Think about those numbers for a second. We would get 4 and 1, and the 4, 4 has to be negative. So we have x minus 4, x plus 1, times our next fraction. In this one, we're going to multiply to 4, add to a negative 5. Anytime you're multiplying to a positive but adding up to a negative, we need 2 negative numbers. So we're going to have negative 4 and negative 1. So we have x minus 4, x minus 1. And lastly, on the bottom, multiplying to negative 3, adding to a positive 2. The only two numbers that multiply to 3 are 3 and 1. One of them has to be positive, one is negative. The one has to be negative. So we add up to a positive 2. So we have x plus 3 and x minus 1. Now, you should notice that some things will cancel. If you don't double check your factoring, they're not typically going to give you problems like this where you can't cancel something out. So we have 3 different things in common. We have an x plus 3 that we can cancel. We have an x minus 4 that we can cancel. And we have an x minus 1. So those x minus 1s are in the same fraction, which we haven't seen much of yet. But as long as it's the same on the top and on the bottom of a fraction, you can cancel. All right, so now let's see what we have left. On the top, we just have an x. And on the bottom, we have an x plus 1. Again, we can't cancel all these x's because this x plus 1 has addition. So we'll go ahead and put the parentheses around those two, just to remind yourself that you can't break that group apart. Okay, let's go ahead and try. Let's get into dividing rational expressions. So before we look at dividing, well, look at some actual examples of dividing rational expressions. We need to review what reciprocals are. So remember that reciprocals are the following. So let's just look at an example. If we had the fraction 5/8, the reciprocal of 5/8 is 8/5. Same thing if you have a rational expression. So let's say we had x plus 1 over x squared minus 4. The reciprocal, we're not changing any signs. All we're doing is flipping the fraction. So we get x squared minus 4 over x plus 1. So there's going to be one question on this on the homework, but we do need to know this for dividing rational expressions, because if you remember, for dividing rational expressions, you're going to multiply by the reciprocal, or depending on what your professor used to remember this, I like to say skip, flip, multiply. I know there's also KFC, which is keep, flip, change, or just multiplying by the reciprocal. There's a few different ways to remember how to divide fractions. Whichever way you remember best, that's what you want to stick to. So if we look at 3/4 divided by 5/16, just like before, we're going back to regular fractions before we look at rational expressions. We're going to skip the first one, so keep 3/4, flip the second fraction, so it becomes 16/5, and then multiply. And now we're back to what we were just doing. So I'm going to go ahead and reduce the 4 and the 16 to a 1 and a 4. That's all we can reduce. So on top we have 3 times 4 is 12. And on the bottom, 1 times 5 is 5. So just remember, skip, flip, multiply. Keep the first fraction, flip the second fraction, and change that division to multiplication. All right, so let's go ahead and look at some problems where we divide rational expressions. All right, and if you hadn't guessed already, after we divide, we're going to write it in lowest terms. Number 1, r over r minus 1 divided by 3r over r plus 4. So first thing we want to do here is change it from division to multiplication. So this is the only time where I'm not going to factor in the first step. This one we can't factor anything, but if we could, I'm going to do it in the step after we change it to multiplication. The only reason for that is that there's less writing to do. You could still factor first and then flip it, but we do have to flip. So keep the first fraction, change it to multiplication, and then flip the second fraction. I'm going to go ahead and throw parentheses around the r minus 1 and the r plus 4 because those have addition and subtraction. We can't separate those guys. So we can't cancel out those groups because there's no groups that are exactly the same as these. There's no factoring to do, but we can cancel one thing. So what is that one thing that we can cancel? Well, we have an r on the top and a 3r on the bottom. Think of that as a 3 times r. Anytime you have multiplication, we can go ahead and cancel. If that were a 3 plus r, we couldn't. But because it's 3r, we can go ahead and cancel out the r and the r. So let me make that more clear. We're canceling the r, not the 3. So now on the top, we have r plus 4. And on the bottom, we have r minus 1 times 3, or 3 times r minus 1. So if you can multiply rational expressions, you can divide because the first step there where you're changing it to multiplication is the only difference. Okay, let's try another. So number 2, 5a squared b over 2 divided by 10ab squared over 8. So again, before you can do any kind of canceling here, we want to go ahead and skip flip multiply. So keep the first fraction the same and flip that second fraction, and then we multiply. So now looking at our numbers and our variables here, they are single terms, so there's no factoring to do, but we can go ahead and reduce. So what is the first, not the first thing, what is one thing that we could reduce here? And you might have said something different than what I'm doing first. So I'm actually going to go ahead and reduce the 5 and the 10 by 5. 5 goes into 5 one time, 5 goes into 10 two times. You can also reduce the 8 and the 2. So 2 goes into 2 one time, 2 goes into 8 four times. And we can also cancel out some variables. So we have an a on the bottom, an a squared on top. So we can cancel out 1a, and if we get rid of 1a on top, we're left with 1a. Same thing with the b's. We have a b and a b squared. Cancel out 1b, we're left with 1b on the bottom. And now if we go across the top, we have a 1 times a times 4. Well, 1 times 4 is 4, and we have an a. And on the bottom, we have a 1 times 2, which is 2, and a b. So you always want to double check your answer to make sure that you are completely simplified, because sometimes you'll reduce your numbers and then some of your numbers will be able to be reduced again, which is the case we have here. So we can go ahead and reduce the 4 and the 2. 2 goes into 2 one time, 2 goes into 4 two times. And now on the top we have 2a, and on the bottom we have 1b, which is just b. Always double check to make sure it's completely simplified. All right, number 3. Let's go ahead and do y squared plus 4y plus 3 over y plus 3 divided by y squared minus 4y minus 5 over y minus 3. All right, so before I start factoring this one, I'm actually going to go ahead and flip it. That way there's a little less writing to do. So keep the first fraction. And multiply by the second fraction flipped. So y minus 3 over y squared minus 4y minus 5. Now let's go ahead and factor. So if we go ahead and look at y squared plus 4y plus 3, it's a trinomial. So I'm going to go ahead and use the big X. We're multiplying to 3, adding to 4. The only factors of 3 are 1 and 3, and those guys add up to 4, so that's good. So we have y plus 1 times y plus 3 over, this y plus 3 can't be factored. So we're going to go ahead and just leave that as y plus 3. I'm just going to throw it in parentheses because those two terms are stuck together. All right, and then in our second fraction here, we have a y minus 3. Again, it's just two terms, they're not squared. There's nothing to factor out. Leave it as y minus 3, and I'm going to put it in parentheses. And then on the bottom, we have a trinomial, big X, multiplying to a negative 5, adding up to a negative 4. The only numbers that multiply to 5 are 5 and 1, but they have to add up to a negative 4. So we need a negative 5 and a positive 1. So y minus 5 times y plus 1. And now try to see what you can cancel out. We can cancel out a y plus 3, and we can cancel out a y plus 1. So the only things we have left here are y minus 3 on top and y minus 5 on the bottom. Again, if you want to put these in parentheses, go for it, or you can leave it just like this. Just know that you can't cancel out these y's because of this subtraction. All right. One more, well, let's go ahead and do two more actually. So this next one we have AB minus A squared on top. On the bottom we have A squared minus 1 divided by A minus B over A minus 1. Again, what is the first thing we're going to do here? Go ahead and flip our fractions. So keep the first one the same and multiply by the reciprocal of our second fraction, so A minus 1 over A minus B. And let's go ahead and see what we can factor. So in our first fraction, we have an AB minus A squared. We only have two terms, and we can actually factor something out of both of these. So what is our greatest common factor? It's going to be an A. So we're left with a B minus, got rid of one A, we're left with another A. And on the bottom, we have A squared minus 1. If you notice, this is the difference of perfect squares. So we're going to set up our two parentheses. A squared is gotten by taking A times A. 1 is 1 times 1. And we're going to put a plus and a minus in between those. If you, again, need to review factoring difference of perfect squares, that's back in chapter 6. I believe it's 6.5 if you wanted to go back and look at that video on my channel. It's going to be the video called Special Factoring Techniques. Okay, and then if we look at this a minus 1, there's nothing in common between those two, so I'm going to leave it as a minus 1. I'm just going to throw it in parentheses. And then a minus b, again, nothing in common. I'm just going to throw it in parentheses. All right, so one thing that we can cancel out here, and it's probably the first one that you saw, is a minus 1. There is one more we can cancel. So what would that one be? You should notice that there are two that look similar, but they're not exactly the same. B minus A and A minus B. These are opposites. So remember, same terms, they've just been flipped around, but they have subtraction in the middle. If they were addition, let me go ahead and point this one out really fast. So if we had A plus B and B plus A, these are actually the exact same. So remember, addition, you can flip it around and it's the same thing. Not with subtraction. With subtraction, we get opposites. So we can cancel these guys out. You just have to make one of them a -1. Doesn't matter which one, I'll just normally put it on the top. All right, so get rid of that so it doesn't confuse you guys. On the top, we have A times -1, which is negative A. And on the bottom, we just have A plus 1. Okay. So I'm going to go ahead and leave it there. I'm going to write this example here, and we can go over this in one of our Zoom sessions. So this one here, 2m squared minus 5m plus 12, or sorry, minus 12 over m squared minus 10m plus 24 divided by 4m squared minus 9 over m squared minus 9m plus 18. So this one is just like we were, what we were just doing. So first thing you're going to want to do is flip that second fraction and then factor and cancel things out. The only thing that might look a little trickier on this one is this one on the top of the first fraction is a trinomial that has a number in the front. So this is one where you're going to need to split the middle term. We saw one like this in 7.1, or you can look at examples on in the chapter 6 videos if you want to look back at those. And this guy over here is the difference of perfect squares, or the difference of squares. So that is, again, stuff that you can see in, I think it's 6.5. It's the special factoring techniques. But again, we'll go over this one together in our little Zoom session. So next section we'll be covering is 7.3. This is where it starts to get more complicated with our rational expressions. We're going to be adding and subtracting them.